Hi folks, today we're going to be solving quadratic equations using factoring. So none of this is going to be new for you. We've done it all in the past, so we'll just get going on it. Remember, our first step is to make sure that our equation is set equal to 0, which we have. So now we can break down into our two binomials. We have plus minus for signs in the quadratic, so we can go plus minus with signs in our binomials. Now, there's only one way we can really break down that 3x squared, and that would be 3x and x. And there's a couple of ways to break down the 8. We could go either 1 and 8 or 2 and 4. And for this, we will go with 2 and 4. So we'll have the 2 here, the 4 here. Now it's important that we check to make sure that it works. Again, we're making sure this is equal to 0 the whole way. Outsides will give us negative 12x. Insides will give us positive 2x. So that gives us a middle term of negative 10x, but if you take a look, we need positive. So our number is right, our signs are wrong, which means the signs are wrong inside the binomial. So we can just switch those around. So we'd have 3x minus 2 and x plus 4. So now it's correct. Now from here, we just set each part equal to 0 and solve for x. So 3x minus 2 equals 0, and x plus 4 would equal 0. So we can just solve for x on each of these. So here we would add the 2, so 3x equals 2, and then divide by 3, so x equals 2/3. The other one, very simple. We can just subtract 4. It's one step and it's done. So x would equal negative 4. So here we've found the zeros, we found the roots, we found the intercepts, basically where this graph would cross the y-axis. Now moving on to the next one. Again, we want to make sure that we are set equal to 0 before we move on, because that's what we're finding. We're finding where y is equal to 0. So now we can break this down into our two sets of parentheses, our two binomials. So our signs in the quadratic are minus minus, so the signs in our binomials will be plus minus. The 4x squared, we can break that down into 4x and 1x, and then, or it can break down into 2x and 2x, but the 4x and x happens to work here. And then the 15, we can break that down into either 1 and 15 or 3 and 5. So in this case, we'll break it down into 3 and 5. And again, it's important that you check and make sure that you did it right. Outsides would give us negative 20x. Insides would give us plus 3x. And that does give us that middle term that we're looking for of negative 17x. So now it's just a matter of setting each part equal to 0. So we'd have 4x plus 3 equals 0. And x minus 5 equals 0. So here we can subtract the 3. So 4x equals negative 3. Divide by 4. So x equals negative 3/4. And the other one is one step and it's finished. So x equals 5. Here's the last one we're going to attempt, and again, it's important that we make sure that this whole thing is set equal to 0 before we solve. So our first step would be to subtract this 4x over to the other side and add the 5 over to the other side. So we have 5x squared minus 20x plus 20 equals 0. Now, when you can take advantage of this, I highly recommend doing it. We have a 5, 20, and 20, which means we can divide a 5 out, or we can factor a 5 out before we do anything else. So factoring out the 5, we have 5 times x squared would give us this 5x squared, minus 5 times 4x would give us this minus 20x, plus 5 times 4 would give us this 20. And we make sure it's set equal to 0. Now it's much easier to factor this thing apart with our two binomials. So minus plus with our quadratic would give us minus minus in our binomials. The x squared would break down into x and x. And the factors of 4 would be either 1 and 4 or 2 and 2. In this case, it would be 2 and 2. From this point, this 5 really does us no good because we could set it equal to 0. 5 equals 0. No, doesn't do anything. Now, these two are the exact same. So we really only need to do the math one time. X minus 2 equals 0. So solving for x, it would be equal to 2. And that happens sometimes where you only get one x coordinate for your root or your x-intercept. And the reason that happens is because your graph would come down and just touch at that one spot, and that would be it. So your vertex lands right on that y-axis, which mine didn't very well, but I have a pen so I can cover it up. There we go. And that is it. Here's your assignment for tomorrow, page 263, numbers 35 through 47 odd, 53 to 57 odd, 62 to 64 all, and then 69 to 77 odd. And when you do 75 and 77, please use elimination. Good luck to you. We'll see you in class.